In this video, we will be detailing the fundamentals of extrusion process, their types and their applications in the manufacturing process. The extrusion process. In extrusion, a cylindrical billet is allowed to force through a die in a manner which is similar to squeezing a toothpaste from a tube. A wide variety of solid or hollow cross sections may be produced by extrusion, which essentially are semi-finished parts. From the Latin word extruder, meaning to force out. A characteristic of extrusion is that large deformations can take place without fracture because the material is under high triaxial compression. Typical products made by extrusion are railing for sliding doors, window frames, tubing having various cross section, aluminum ladder frames, and numerous structural and architectural shapes. Commonly used extruded materials are aluminum, copper, steel, magnesium, and lead. There are three basic types of extrusion in most common process called direct or forward extrusion. A billet is placed in a chamber, which is a container, and forced through a die opening by hydraulically driven ram, which is also called the pressing stem or punch. The die opening may be round or it may have various shapes depending on the desired profile. An important feature of the extrusion process is that the grain flow of the material lies in the direction most suited to resist the applied stress during usage. Then the other types of extrusions are indirect, hydrostatic, and impact extrusion. Then the classification mainly includes hot extrusion and cold extrusion. Again, hot and cold extrusion is classified into forward and backward. The name implies in hot extrusion, the billet is heated to a temperature above the recrystallization temperature or at elevated temperature. Then, in cold extrusion, it is again divided into three: hydrostatic, extrusion forging, and impact. Both in hot and cold extrusion, the forward extrusion implies the extruded metal flows in the same direction as that of the movement of the ram, and hence the name forward extrusion. It is also called as direct extrusion. So in the case of backward extrusion, the extruded metal moves out in the opposite direction of the movement of the ram. This process is also known as indirect or reverse extrusion. Extrusion at room temperature or at temperature lower than the recrystallization temperature of the work material is known as cold extrusion. It is developed in the 1940s. The cold extrusion is a general form that denotes a combination of operations such as direct and indirect extrusion and forging. Cold extrusion is widely used for components in automobiles, motorcycles, bicycles, and appliances, and in transportation and in farm equipments. The magnitude of the stress on the tooling in cold extrusion, however, is very high, being on the order of the hardness of the workpiece material. Tooling design and the selection of appropriate tool and die materials are crucial to the success of cold extrusion. It is primarily used to produce parts in finished or nearly finished form. Cold extrusion has the following advantage over hot extrusion. They are improved mechanical properties resulting from work hardening, provided that the heat generated by plastic deformation and friction does not recrystallize the extruded metal. Good control of dimensional tolerance, reducing the need for subsequent machining or finishing operation. It has improved surface finish due partly to the absence of oxide film and provided that the lubricant is effective. Production rate and costs that are competitive with those of other methods of producing the same part, such as machining. Some machines are capable of producing more than 2000 parts per hour.
Hydrostatic extrusion. What is hydrostatic extrusion? It is a process in which the billet is completely circumscribed by a pressurized liquid in all the cases, with the exception being the case where the billet is in contact with the die. This process can be carried out in many ways, including warm, cold, or hot, but due to the stability of the used fluid, the temperature is limited. Hydrostatic extrusion has to be carried out in a completely sealed cylinder for containing the hydrostatic medium. The fluid may be pressurized in following two ways. Constant rate extrusion. In this, a ram or plunger is used for pressurizing the fluid in the container. Next is constant pressure extrusion. A pump with a pressure intensifier is used for pressurizing the fluid, which is then pumped into the container. What are the advantages? There is no friction amidst the container and billet. This minimizes the force requirements, allowing higher reduction ratios, faster speeds, and lower billet temperatures. Friction of the die can be largely reduced by a film of pressurized lubricant amidst the die surface and deforming metal. On applying high pressures, the ductility of material increases. There is an even flow of material. Next are the disadvantages. The billets have to be prepared by tapering one end so that it matches the die entry angle. This is essential for forming a seal at the starting of the cycle. Generally, the complete billet is required to be machined for the removal of surface defects. It can be difficult to contain the fluid under the effects of high pressures. In this 3 slides for hydrostatic extrusion, I have given 3 different figures. Now, the figures are the same, but depending on which suits or the figure which is more understandable can be used for understanding the hydrostatic extrusion. Thank you.
Impact extrusion. Impact extrusion is a manufacturing process similar to extrusion and drawing by which products are made with a metal slug. The slug is pressed at a high velocity with extreme force into a die or a mold by a punch. How impact extrusion works? To perform impact extrusion, manufacturing companies need either a mechanical or hydraulic press. The metal slug is positioned between a punch and a die. When activated, the press will move the punch down onto the metal slug, thereby forcing the metal slug through the die. The metal slug will then take the physical properties of the die. After the metal slug has been forced through the die, it's removed via an ejector. Advantages of impact extrusion. Although there are other extrusion processes available, impact extrusion has become a popular choice among manufacturing companies. For starters, it's considered a cold working process, meaning manufacturing companies don't need to heat the metal slug beforehand. The metal slug can be deformed at a near room temperature thanks to the superior power offered by the press machine. In conclusion, impact extrusion is a manufacturing related extrusion process that uses a press along with a punch and a die set to form metal slugs. It involves placing a metal slug between a punch and a die, followed by engaging the press so that it forces the metal slug through the die.
I myself, Rocky Zakaria, would be talking about the topic extrusion forging. So before we proceed, let us be clear with the heading extrusion forging. As you all know, forging is the mechanism in which a metal is deformed by applying a high compressive stress. An extrusion is the process in which this deformed metal is made to pass through a die orifice to get the required shape that is needed for the production of the metal. So as you can see, the basic tools used in the extrusion forging are punch, slug and die. The slug is also called as billet, and billet is placed between the pair of die, and punch is the one that deforms the metal, and ejector is a small opening through which the deformed metal can be obtained. We'll discuss how it works in the next slide. Let us discuss about the principle or working mechanism behind extrusion forging. So extrusion forging, as we discussed, it's a mechanical process where a metal is deformed by applying high compressive pressure with the help of a die and punch. The punch, also called ram, helps in deforming the metal by applying high compressive stress. The die is a small opening that is located at the exit of the extruder, and its main role is to shape products in different sizes and structures as per our desire. The die is designed in a manner so as to withstand the pressure and temperature of the heated billet or metal as it flows through it. And the extrusion forging mechanism is also called as a backward extrusion process. It's because it is, as the word suggests, it's because the product that we obtained comes at the back of the die, and that is the main reason why it's called a backward extrusion process. Next, we'll be discussing about the merits of extrusion forging mechanism. And its merits are the following: low cost of operation. The operation is of low cost since the mechanism is quite simple, and less number of inputs and less number of tools are required for this mechanism. A lot of tons of products can be produced. It's a continuous operation. A good surface finish can be obtained by carefully setting the values of compressive stress, selection of die, and the noting down the temperature, and a good surface finish can be obtained. It's a fully automated mechanism where the inputs can be given to a machine, and the machine works as per the inputs given to the system. Next, we will be discussing about the limitations of the extrusion forging mechanism. The first limitation is development of surface cracks. So the surface cracks are formed due to the piling of high residue stress on the surface. So if the pressure that we apply is more than the pressure that the material can handle, then surface cracks are developed. Next, variation in the size of the material, which means the size of dies and the presses that can be economically built is a limiting factor. And next comes the product limitation, as only one type of cross section can be extruded at a time and not many types, and that is another limitation which can be seen in the forging mechanism. And another thing is it is high initial cost setup. So setting up an extrusion forging mechanism which involves a die and the making a die is also very costly. It's also costly when compared to other techniques like rolling, forging, etc.